Hello everybody, I am Nandakumar, a faculty from Computer Science and Engineering Department of Maharaja Institute of Technology. So, I have been allocated a subject called as Advanced Computer Architecture. So, I am going to teach you this subject or this course throughout this semester. So, let me write the title of the subject, Advanced Right, the subject code is 17CS72. Don't worry about the subject code, we will deal with it later. Right, now if you look into the subject code Advanced Computer Architecture, now before I get into the introduction of this, now the first course that you would have learned on a computer science is a C program. Right, in the C program, the very first thing they would have given you a block diagram of a computer. Now, let me recall that block diagram of a computer that you have studied in your first semester. Now, basically it contains 3 blocks, block 1, 2 and 3. So, some textbooks could have 5 blocks or some could have 3, some could have 4, but I am making it as 3 blocks. This is going to be input output block. I have merged it together, but when you have studied in your first semester, it could have been 2 different blocks, right. This is the first one. The second one is memory. The third one is processor or processing unit, right. Now, do you recall this block diagram? I believe most of you would recall this block diagram, and again all these blocks are interconnected. Now, again, so there is interconnected, this interconnection is through a set of connecting lines, and that set of connecting lines is usually referred to as a bus, right. Now, a memory, a processor, a input device, a output device, all together is put inside a box. That box we call it as a computer. That is what you would have studied in your first semester, right. Now, apart from this, if I ask you the details of all this, now what is the function of each block, then you would start to say that input output is basically used for either accepting the input or generating the results here and then displaying using a output, right. Now, a processor and then a memory. Memory is basically used for storage. Now, a processor on its own cannot store anything, its job is only to do the computations, it cannot store anything. So, to make up that you need a memory. Memory works in tandem with the processor to accept, right. Now, again if you look into the processor, you would have come across 2 blocks here. The first one is, I am going to call it as control unit, and then the other one is ALU. Control unit and arithmetic and logic processing unit, ALU, control unit, right. Now, as the name itself says, the control unit is basically used for controlling everything. It could be fetching a memory, it could be controlling a IO device, it could be controlling the bus operation, everything. So, all the controlling operations are going to be taken here by the control unit. Now, what is the job of a ALU? The job of a ALU is simply to do what is being told as per the instructions. So, it is almost what is being said is going to be done. Now, when you look into the design of a ALU, it is very simple, because what needs to be done by ALU is known to it, right. Once the job is known to it, automatically designing it becomes very easy. The job of a ALU is very simple. Whatever is being told by the control unit and whatever is given by the memory, it takes the instructions and the contents from the memory and simply executes it, right. Now, if you look into the design of a ALU, it is a very simple one, but if you look into the design of a control unit, so this is where you see a huge change that has happened over a period of time, right. Now, coming to the memory, here also you see a huge change that has been made in the way a memory is being accessed, the technology that is being used, etc., etc. You see a huge change in the things, the way a memory is being done. Clear? Now, if you look into the history of a computer, I would hardly say it dates back somewhere around 60 years. So, it all started with 1960s is the period where you started to hear the word computing, and 1970s is the year where you would see a IBM coming into a picture of making a personal computer. If you remember the IBM PC, no, I would say that this one is the one that revolutionized the way a computer is being done. Earlier a computer was used basically for scientific computations. So, it was not known that a computer could be used as a tool for entertainment. It was not known that a computer can be used as a tool for computation. It was used, it was not known that a computer can be used in a business application. It cannot be used for a entertainment. It was known only that it is meant for a scientific computations. But with the introduction of the personal computers by the IBM in the late 70s, 72 or 73, then the complete picture of a computer started to change. Right? Now, it is where from this I am going to say that every now and then, as the need increased for it to be elaborated across multiple requirements, there you started to see a advancement in the technology that is being used. You are getting the point here? Now, as and when the need arised, so that need started to relook into what was being initially looked. Right? Now, initially this personal computer was called as a sequential machine. It used to take the instructions and execute it sequentially. Now, this sequential concept was there for I would say almost for 30-40 years it was there. 30-40 years this sequential computing concept was there. But now, as I said, no, it is the human tendency wherein he wants more. I would simply say it is a dil mange more concept. No, he was not satisfied with what he was having, he wanted more. Now, that is where somewhere this sequential concept was needed to be relooked. Now, this concept of relooking into the sequential computing started to emerge in 2000. Yeah. So, from there around 2002, 3, 4, now you see a concept of parallel computing. So, the concept of parallel computing started to emerge. Now, the question arises, what was the need for this parallel computer to emerge? Now, as I said, no, in the last 30-40 years, whatever was the technology that was possible to be developed, now you see a cease in the technology of a memory that was used. You see a cease in the technology that was used for computing, because whatever processor design that you come out, always there is a physical limitation that is being imposed by the physical material on that. Now, they have reached that maximum physical limit, but still the user are not happy with it. They wanted the performance to be increased. Here a performance here refers to a less time, less resources needed for accomplishing a given task. So, that is where from a sequential concept they started to move to parallel computing. As the name itself says, parallel computing, instead of you doing sequentially one after another instruction execution, because your ALU simply takes the instructions that are stored in the memory and started to execute one after another. Right? Now, if there are 10 instructions, and I would say that it takes around 10 units of time, but I wanted this 10 unit of time to be reduced, because I do not have a patience to wait for 10 units of time. Now, the question arises, what should we do now? Now, what should I do to reduce this? What should I do to reduce this? This thought process started to get evolved in the late 2000, and then that is where they started to, instead of executing sequentially, they started to execute parallelly. Right? If there are 10 instructions, if there are no dependency, and if you are 2 processors allocated the same job, then instead of 10 units of time, that could be reduced to 5 units of time plus some delta time. Now, what is this delta time, etc., we are going to study in detail later. But now, on a logical point, now if one processor is taking 10 units of time, if I allocate 2 processors to do the same job, then automatically we think that it is going to be half the time. right. Now, it is going to be 5 units of time is going to be taken for executing this program. So, somewhere I see a enhance in the performance. Enhance in the performance here is the time that is needed for completion is going to be reduced, right. Now, that is where the concept of from a uniprocessor it moved to multiprocessor. You are getting the point here? Earlier it used to be only one processor here, but since they wanted the job to be executed parallelly, they thought of giving a redundant processing unit, so that instead of one they started to add one more processor and the job started to split, right. Now, when this design started to emerge, now again one thing needs to be looked into, right. Now, until this 2000, whenever you wanted to look into the performance enhancement, it used to be a hardware. Always the performance enhancements was always with respect to hardware, right. Now, as I said, now by this 2000, whatever the technology that was used for fabrication of processors, high density VLSI, etc., it almost came to a physical limitation. Now, they started to move from a hardware to a software based. Now, that is where the concept of parallel programming, etc., multi-programming all came into picture, right. Now, look into this. The emphasis was on improving the performance of a hardware to increase the performance. Now, once when it reaches the limitation, then they started to move into look into the software. Now, they started to work with the software wherein they are going to split the job and allocate it to multiple processors, so that the total response time is going to be reduced, or inversely I would say the performance is going to be increased, right. Now, when I use the word advanced computer architecture, now from a hardware they started to move to a software approaches for increasing the performance. Now, that started in 2000, and by 2004, 5, etc. So, this concept of software based architecture advancement came into picture, right. Now, this process almost it lasted for around 15 years, but nowadays when you look into a processor requirement, or when you look into a requirement of a hardware or a software, now what is the thing that you do now? Now, do you look into the hardware, the software, and then you come out with an application? No. Nowadays it is not the hardware, it is not the software, it is the demand of the application demand that is driving it to advance, right. Now, for example, if you take an example of a predicting the weather or forecasting a weather, now if you look into the amount of data that is being analyzed there, it is very huge. The huge amount of data needs to be analyzed in a very given period of time, right. Now, that thing, or if you look into the other entertainment, if you recall a Bahubali picture, now you see more graphics rather than the camera work there. Now, when I say the word graphics, what is it that we are looking at? Somewhere somebody is working in a shadow. That somebody is again a computer that is working there. There the specific requirement is with respect to image, with respect to the data analysis, right. Now, the point that I want to emphasize here is, at the earlier stages it used to be the hardware requirements, later it used to be enhancement used to be with respect to software. Now the requirement is with respect to the application specific or domain specific, right. Now, this is how a architecture started to get evolved. I am using the word evolved. Evolved means a slow changing process. Even though when I say a 60 years is a very long period, but when you look into the other inventions and discoveries which has taken centuries to get stabilized, now this 60 years is a very young period, right. And that too in the last 20 years, whatever changes that you are seeing with respect to the computing, it has made a huge impact that unknowingly or knowingly we are all dependent on the computer, right. And why this dependency has occurred? Because your computer was able to answer all your needs. I am repeating the point, your computer was able to answer all your needs. So, that is where from a hardware specific to a software and then to a application, it was able to address, right. Nowadays this COVID period, no, you would see a lot of data being collected and then data analyzed, and then they are predicting that in another 1 week your cases is going to be this much, etc. So again they are analyzing the data. When you want to analyze the data, huge amount of data is available. So that needs to be organized, and from that you need to get clustered, and from that you need to make some interpretations, and then you derive a conclusion. Now for doing all this, somewhere a computer is going to be used, right. Now but when you talk about a single uniprocessor computer, so that was a talk of a town in late 70s. Probably it takes I would say decades to come out with a result, right. But when you talk about the present day computing power that is available in a layman's hand, now that is able to do this. Now all this is possible because of the advancement of either the controlling unit, arithmetic logical unit, or memory, right. Now I would say that all have started to evolve based on the needs. Initially this hardware was a market driven, because IBM and then Xerox, all those wanted to be marketing leaders. Now that is where a 4-bit processor got 8-bit, 8-bit got 16. So there it was a race for capture the market in the initial phase. That is where the hardware started to get evolved. Now later the software was able to take up, because it was able to address to a certain extent, but at the end it was the application, or I would say the domain. Now either the application or the domain, so that is driving the need for advancement in the architecture. Clear? You got this? Now this is what made us to look into a computer architecture. Clear? Right. Now if you look into the evolving of the technology, it was first the technology, the second one was it was the need that has arisen, and then the third one is the product or the application or the domain that is driving people to be better in everything. It could be evolving of the memory technology. Earlier it used to be flip flops and everything, but now you have got a storage memory which is very affordable. Now when you look into the computing processor, now if I want to give an example, the computing power that your mobile has got is much more many times better than the computer that was used for launching a man on a moon, right. Now that is the capability. All this is because of advancement of any one of this one, right. Now this, or I would simply conclude that it is the attitude of a dil mange more that made us to get ourselves evolved with all the aspects of a computer, right. Now the basic architecture of a computer is same. It is simply 3-block computer, input output, this one and this one. But where do you see the advancement? Advancement is either with respect to the processor, either advancement is with respect to the memory technology, or with respect to the IO. Nowadays even if you talk about IO interfaces, now there is a lot of emphasis is being put on interface. Earlier it used to be this and this both started to emerge parallelly, because if this grows, automatically this needs to support, and if this grows, automatically this is going to grow. Now this both started to grow parallelly each other, but not much emphasis was given to interface IO at the early stages. But now if you look into this, the way it is getting interfaced is very different. So somewhere they are using artificial intelligence or your mood, etc., for analyzing your input. Earlier your input, when you look into the earlier, a input device used to be either a keyboard or a mouse, but now you have a array of input devices. Now that is again getting evolved, and again a array of output devices. And when I say if it is a domain specific, always your input output devices may not be a standard devices which is visible to us. Now again it could be a much more different one, right. Now the need for this had made us to make sure that everything gets evolved. It is not an emerged one, it is evolving from one to the other. And as I said, no, it is the hardware that evolved first, then the software supported it, and then the application needs is driving that enhancement. Clear? Now, this is what we are going to look into in a advanced computer architecture. When you are looking into the syllabus, now a module looks into what needs to be done to enhance the performance of a memory, or what needs to be done to enhance the performance, and then what needs to be done to enhance this. But this is not going to be discussed. We are going to look more on this and this. Now, as I said, now the emphasis on this is going to be not much earlier, but now the emphasis is going to be more on this, because as I said, now almost the technology and the product are getting to a maximum stabilized limits. Now, they are looking into this, right. Now, if you want to go through this course, there is a prerequisition that needs to be understood. Now, prerequisition is, if you want this ACA to be understood properly, the prerequisition for this is you should understand the concepts of computer architecture. Now, I believe for our students we do not have a course on computer architecture, but no problem. But prior to that, you would have had a course called as CO, computer organization. Now, what is it that you have studied in that CO? You would have looked into the same block diagram again is studied in CO also. Yes or no? But there you are referring to it from a functional point of view. Functional point of view, right? After that CO, somewhere you would have studied a microprocessor, no? 8086. I believe you remember that word 8086. I would say that this processor 8086 was a game changer in computing industry. 8086 was a game changer in computing industry. That is where you see a huge thing, because it made it possible for a computer to be able to be placed on a user's desk, personal computer. Earlier, when you imagine a word computer, it used to be a big huge room, but this made it possible for a computer to be placed in front of a person on his desk. That is where the desktop came into picture, right. Now, you have studied 8086 architecture, functioning, programming, etc., etc. You have studied computer organization, etc., etc., right. Now, if you want to understand this CO, or let me draw out a connection. What is the connection between this computer organization and 8086? Again, you are learning about a computer architecture. When you look into the CO, the entire concept is going to be discussed with these 3 blocks only, and again in 8086 also it is going to be these 3 blocks only, but here it is specific to one architecture. So, it is Intel specific to one architecture. Here we are studying with respect to functional point of view. Now, if you want to understand this computer organization better, then probably you would have studied another course called as now LD. You remember logic design, because your computer is simply a machine that is used to choose between true or false, yes or no, right. Now, you would have come across a course on logic design. So, there you would have studied many circuits. Now, out of all the circuits that you have studied, I would say adder. You remember the word adder, no? Because that word adder would have fetched you lots of marks, not less than 20 marks in your logic design question paper, right. Now, this adder is a very, very important one in a computer, because any computations that are made in a computer is simply addition. It only knows one operation, addition operation. It cannot do a subtraction, it cannot do multiplication, it cannot do division. But this addition, a small modification is able to perform subtraction. A small modification of addition is able to perform multiplication. A small modification of this addition is able to perform division, right, or even a power, etc. When I say compute x to the power of y, means it is nothing but x needs to be multiplied y times, and again what is x needs to be multiplied y times is nothing but x needs to be added x times, and then again it basically boils down to an adder. And if you want it to be designed as a subtractor, again you would remember the concept of 1's complement, 2's complement approach. No, it is nothing but you are modifying it to mimic as if it is performing a performing a subtraction, but basically it is performing a addition operation, because all your computer knows is simply addition operation, rest all is a modification to mimic as if it is performing either multiplication or division or subtraction, right. Now, this is what you are going to study, you have studied in logic design. As the name itself says, you are going to look into the design of a circuit at a logical level, right. Now, the prerequisite for understanding this logic design is you would have understood the DMS, no, discrete mathematic structures, very important subject, but a very hard subject for most of our VTU students who prefer to study it in a point of passing rather than understanding. But I would say that the one who understands this discrete concept properly, completely, then rest all becomes a easy work for him. You are getting the point here? Now, if you understand this DMS, rest all becomes a easy work. If you are not able to get it clearly at this point, no, rest all is a difficult path to move about, right. Now, this you would have studied in your third semester, this you are going to study in your fourth semester, and this one I think it is in fourth semester, this you have studied in fifth semester, and then sixth semester no subject on computer architecture, and then you are going to move to advanced computer architecture. This is all with respect to the hardware requirements. Again, on the other requirement, somewhere you would have studied a programming language, no, a C programming language, and then in another semester you have studied assembly language program, right, and then again somewhere you have studied high level language programs, right. So, this plus this both together is needed to be understood for a complete understanding of a advanced computer architecture. Clear with this? Now, if you want to walk easily through this advanced computer architecture, the prerequisite is somewhere please look into the concepts of computer organization and 8086 processor, then the logic design subject, and then the DMS subject, and with a brief knowledge of any one programming language. I am not saying that it has to be the Python or any one programming language, because the way you talk to your computer is with a programming language, because the computer understands us only through a programming language. Now, if you are able to understand a programming language, then your communication with your computer becomes easy. So, that is where I am asking you to look into any one programming language and then brush up all these things, so that it becomes easy for us to walk through the computer architecture course.